All right, here we go. We have a lot to do. So I'm going to start by handing out your practice tests. So hang on to these. We're not going to need them just yet. But everybody's hand.
I need all you to present, so I don't have to go. It'll be long. Start playing. Take like 20 minutes. Because one person will go, you come here this.
All right, everybody have a practice test. Okay. Now, I'm going to give you a practice quiz. Because next time we're together, which I think is tomorrow, we're going to have a quiz. Alright, so let's see what's on this thing. Also, speaking of tomorrow, last day for ministerial, if you're planning to do that. I have something.
How many volumes is it, Miss Ford? Two? Two?
Two's maximum, yeah. You can bring in one if you want.
Can I bring in a couple and then anybody who doesn't have them, they can just use that?
You can do whatever you want with your cereal, right?
You can bring me
You can bring me some. All right. Or Phoebe, you can go to the store and get your own. All right, here we go. Practice. Evaluate. Sine 3 pi over 2. Tangent negative 210. Cosecant 5 pi over 6. Okay. What are you going to do first with this?
Convert.
Okay, so if we change that, we know pi is 180. 2 into 180 is 90, and 3 of those is 270. Okay? Where's 270? It's on an axis. And I kind of gave it away because it's automatic for me. But when we have an angle on the axis, we draw a circle, not a triangle. Okay, and it's down here. Would everybody agree 270 is down here? Okay, I'm going to let my radius be 1. What does that make this point that's straight down? 0, negative 1. So x is 0. Y is negative 1, and R is 1. What is sine? Y over R, which will be negative 1 over 1 or negative 1. So the answer to the problem, negative 1. All right, negative 210. Now, where is that? Well, first of all, it is negative, which means I'm going this way. So that would be 90. That would be 180. I don't want to go all that way. Isn't it going to be like right in here somewhere? That's negative 210. Now I'm going to make a triangle because this one is not on an axis. It's sticking out there. This is 180. What's this?
30.
30. Guys, right here. 180, 210. That's a 30 in between those fingers. And if that's a 30, then this is a 1. This is a root 3 and this is a 2. Because that's how it works in a 30, 60, 90. But be careful, I'm in quadrant 2, which means that one has to be negative. I'm noticing in your homework, some of you are leaving out the negatives. Gotta pay attention to where you are. Tangent, opposite over adjacent. Y over X, whichever way you think about it. Negative root 3 over 3. Okay. What's the first thing you're going to do with this one?
Evaluate.
Change it into degrees. So 6 goes into 180.
Oh, is that on our practice?
30.
There's no 5. Yeah. It's just
5 over 6.
Oh, just pi over 6. Oh, shoot, sorry. Okay, well, that's even easier. 180 over 6 is 30. Sorry about that. I don't know where I got 5. Who knows? Okay, 30 degrees is here. Again, you've got 1, root 3, and 2. And because I'm in quadrant 1, the whole shebang is positive. Cosecant is reciprocal of sine, so it'll be hypotenuse over opposite. The answer is 2. And cosine, 225. All right, where's 225? It's positive, so I go this way, right?
Like what? Third.
Want to be right here? In between 180 and 270. So I'll make a triangle. Now that angle I drew, this guy right here is 225. So what's the angle in between here, in the triangle here? 180 to 225 is 45. Which means my sides are 1, 1, root 2. And because I'm in quadrant 3, those are both negative. Cosine, adjacent over hypotenuse, or x over r. Either way, it's negative 1 over root 2, negative root 2 over 2. Okay with all? All right, backside. Ooh, this is two-sider. Whoa.
Shoot.
All right, what are we doing on the back? We are sketching. So we know how to do this. This is a sine. In a normal world, a sine looks like this. And those would be my labels for a normal sine with no changes. Excuse you, bless you. Now, we have made some changes. What have we done?
The 2 out in front. Change.
2 out in front multiplies these
Yeah,
numbers.
so it's negative 2.
So this is gonna be a 2 and a negative 2, which means my amplitude is 2. What does this 3 do? Divides all of these. So the labels that actually are going to go on the axis, right here, the labels that you're gonna write there are 30, 60, 90, and 120. And remember, if the division equation is bothering you, you just figure out the first one, and then just keep adding that number on. So what's my period? My period is 120 degrees. Okay?
And every period's just gonna have 4 marks, right?
Or a sine and cosine, yep. Okay, here, Keegan. All right. Now, negative 1/2 cosine 2x. Now, be careful, this is a cosine. So, normal labels apply, but it's a negative. Which means what?
The picture.
Instead of starting up
Oh, you start next.
here, it's going to start down here and go up. So we're making very sure that we are putting our points right where Mrs. Ford is putting them. Okay, now how about labels? This y-axis will be 1/2 and negative 1/2. So my amplitude is a half, positive. What about these? What's happening to these? They're being divided by 2. So what's 90 divided by 2? 45. So then you can either divide all these by 2 or just keep adding 45. Whatever's easiest for you. And the period is 180. Now we have a tangent. Asymptote, negative 90. Asymptote, positive 90. Squiggly line up through the origin. Right? Now, what's changed?
You gotta divide the 90s.
These guys are divided by a half, and 90 divided by a half is the same as 90 times 2. So 180 negative and 180 positive. What's my amplitude? None. There is no amplitude for any tangent ever. And what's my period? Yep, 180 to negative 180, 360. All right, are you ready for that quiz? Practice, practice, practice.
That's tomorrow.
That's tomorrow.
Do we?
Huh?
Tomorrow's Friday, right?
Mm-hmm.
I thought we can't put it on Friday.
Yeah, that's
Semester 2 rule.
some rule, yeah. Okay, we have 2 more problems from 4.7 number 1 to finish.
I think we just have the last. Oh, never mind.
2 more.
Sorry.
We have I and J from number 1, and then we still have to do number 2. Okay. Now, here's something new and exciting. Whenever a 0 is involved, I want you to think about this for a second. Tangent is y over x. Opposite over adjacent. Well, is it possible for the opposite side of a triangle to be 0? No, there's no triangle. If there's a 0 involved, you are somewhere on the circle. Because, yeah, on an axis. Because isn't this where the zeros happen? They don't happen out here. So if your problem has a 0 in it, you're gonna look here. If your problem has a sine or cosine with a 1, you're gonna look here. These are circle problems. Because, if you think about it, you cannot draw a triangle where that and that are both 1. Is that possible? No. And when the triangle isn't possible, then that means you look at the circle. So these numbers are clues. Okay, now look around the circle. I've labeled all my points, and some of you struggle with that. I can't fix that. You just gotta use your common sense. Here's the origin, that's 1, 0, 0, 1, and so on. Which one of these points gives me a 0? Start here. If I put y over, I'm starting here because this is 0, this is 90, and so on. Start at 0. If I put y over x, 0 over 1, do I get 0? That's the answer to the question. The answer to the question is 0 degrees. Where do you get a tangent that's 0? You get a tangent that's 0 at 0. Up here, you would get a tangent that's undefined. Right here. Now, where do I get a sine that's 1? Well, again, think about your circle. And what is sine? Y over r? Where does it happen that if you put, remember, r is 1. Where does it happen that if you put y over r, you get 1 over 1 or 1? Right here. Isn't that where that happens, right there? So what's the answer to this question? 90 degrees. Now, so there's no confusion. When tangent is 1, that is out here because tangent can be 1. 1 over 1. But if sine or cosine are 1s or 0s, you're on the circle. If anything is 0, you're on the circle. But if sines and cosines are 1, you're also on the circle because it is impossible. You might try. You might say, oh, I'll try drawing that. And that should immediately tell you, whoa, that's not possible. Okay? Okay. All right, now, number 2. I always get a kick out of these because kids look at these and think, oh my gosh, these are horribly difficult. But these are so easy. When we do math, where do we always start? When you think about PEMDAS, where do we always start? In the parentheses. So I'm going to forget about this for a moment, and I'm just going to look at my parentheses. That says that I have an angle in quadrant 1. How do I know I'm in quadrant 1? Positive. And opposite over adjacent is 3 over 4. Would everybody agree with that? Now, what are you kind of programmed to do at this point? Pythagorean theorem. Find the hypotenuse. Okay, so go ahead, find the hypotenuse, just like you always do. What'd you get? 5? Now, some of you goofballs, in homework there was a problem like this, and you put square root of 25, and I took off half a point. That is sheer craziness. Square root of 25 is 5. Okay. Now, this is not one of my special triangles. This isn't a 30 or a 60 or something. These are the wrong numbers. But the good news is, I don't even care. I just need to know the sign. So this is a picture of my angle, and now I'm just going to tell you what the sign is. Okay, so what's the sign? 3 over 5. Your angle's here, so the answer to the problem is 3 over 5. So the parentheses is where you start, like always. So start here. See how that number's positive? So you're gonna draw it in quadrant 1. Opposite over hypotenuse because it's sine. Remember, this is covered up. This is all I'm looking at. Okay, carefully do your Pythagorean theorem. I hope you got 12. Now, beautiful picture. What do I want to know about it? What is its cosine? So the cosine will be adjacent over hypotenuse, 12, 13. Isn't that easy? So easy. Okay. Now, the next one, we have a problem. What's the problem? Remember, we're doing the parentheses.
It's negative.
It's a negative, so Ms. Ford has to tell you we're in quadrant 4. And the sign is negative 4/5. Remember, that's your angle. So opposite over hypotenuse. Okay, do your Pythagorean theorem again. Okay? What'd you get? 3, and that would be positive, right?
Yep.
Guys, you gotta get this right. A squared plus B squared is C squared. That's the setup. Okay, now, there's my picture, beautiful. What do I wanna know about it? I wanna know the tangent. So the tangent will be opposite over adjacent, negative 4/3. Okay. I'm gonna start by drawing a picture. Right here. What quadrant?
The first.
Tangent is 2/3, opposite over adjacent. Okay? You know what to do. I handed those out before you got here. We have quiz tomorrow. It'll be on video, guys, to watch it. Okay, what do I get for my hypotenuse? Root 13. Now, what do I want to know? I want to know the cosine. So I look at my picture. Cosine is adjacent over hypotenuse, or 3 root 13 over 13. All right, we need one more together, and then you can do that last one on your own. So here we go. Shall I draw on quadrant 1 again? Yep. Cosine, root 7 over 4. I'm not gonna worry, I'm not gonna panic about the radical. It's all gonna be fine, because the Pythagorean theorem says root 7 squared plus b squared equals 4 squared. And what's root 7 squared? 7. So it looks like b is 3. I want sine. Sine is opposite over hypotenuse, 3/4. All right, try the last one. See if you can draw a picture of it. That's your first thing. And then find the tangent. Okay, anybody get a hypotenuse? I'm not a hypotenuse, I have a hypotenuse. Anybody get an opposite side over here? Root 7? Because 3 squared plus b squared is 4 squared. So b squared is 7. So b is root 7. Now, what do I want? I want the tangent. What did you say the answer was? Root 7 over 3. Opposite over adjacent. Got it? All right, let's get those calculators out. And let's do a couple of review word problems. And I say they're review because when I read it, it looks familiar to me. Didn't we do several of these one other day? So we have a tree. There's my tree. And I have a bird up in the top of the tree. And there is a point on the ground 100 feet from the base of the tree. So where does the 100 go? Right down here, right? And I want the angle of elevation, which is right here. The bird is 18 feet above the ground. Now, you need to remember the key things we talked about when we did this before. Remember how our angle of elevation or depression always goes right here. This is where you put your angle. Then you have to look at your scenario. This is the angle. Which side is this? Opposite, adjacent, or hypotenuse? Opposite. Which side is this?
Adjacent.
So you're always going to pick sine, cosine, or tangent. Which is it gonna be in this problem? Tangent. And as soon as you write tangent, you attach to the angle. The angle is what goes with the tangent. Equals opposite over adjacent.
Do you want us to consider that x or theta?
Doesn't matter.
Doesn't matter.
Now, who remembers how we find an angle?
Inverse.
We use the inverse. So x is gonna be the inverse tangent of 18 over 100. So then I have to go to my calculator. Real quick check, press mode, make sure you're in degrees. You probably are, but just in case. And then second tangent, 18 divided by 100. I got 10.20 degrees. Did you? All right, B. Find the distance from worm on the ground to a bird in the top of the tree. Okay, so we have another bird in the top of the tree. And then we have a worm out here on the ground somewhere. The angle of depression is 24. The tree is 19 feet tall. Are my numbers making sense to you?
Yep.
Now I need an X. Find the distance from the worm to the bird. So where does the X go?
Up by the nose.
It's on the hypotenuse. It's the hypotenuse. Worm to bird. Okay, so here's my angle. Right? Which sides do I have? I have this one, which is opposite. I have this one, which is hypotenuse. So this will be sine, cosine, or tangent?
Well, you have
Sine. Sine 24, always put the angle with the sine. Sine 24 equals opposite over hypotenuse. So then we'll get rid of the x. No, we don't want a denominator. And then divide. So 19 over sine 24. Now, am I gonna use my inverse button? Oh, no. I only do that when my question mark is the angle. So I'm just gonna type that in. 19 divided by sine 24. I got 46.71 feet. Okay? Now what have I got? I got a flagpole. Casting a 23-foot shadow when the angle of elevation is 32 degrees. And I want to know how tall is the flagpole. Does that much make sense to everybody?
Yeah.
Okay, here's where, for some reason, we are goofy. there's a 23-foot shadow. So somewhere in that picture, I have to put a 23. Where does it go? On the bottom, because shadows are on the ground. What function? You need sine, cosine, or tangent. You're gonna write an equation like this one. You need sine, cosine, or tangent. Which one are you gonna use? And you chose tangent correctly, by the way, because you have opposite and adjacent. Remember, the 32 is hooked to the tangent. The angle is always hooked to the function. So the times by 23, and I'm done. That's the answer to the question, whatever that is. 23 tangent 32. I got 14.37 feet. Did you?
Yeah.
Okay. And then we got a couple where all we're doing is drawing them. This is getting us ready for chapter 5. All we're doing is drawing these. Okay, so we haven't done this in a long time, before Christmas. Would everybody understand that this is a navigation type problem? I'm giving directions here. And whenever I have a problem where I'm giving directions, I use a compass setup, which is different than a math setup. The math setup is always this. This is your math setup. But if you're giving directions, anybody remember the compass setup?
North, south, east, west.
Yeah, so this is 0, due north is 0. 90, 270. So it's different. Sorry, it just is. If you're doing navigation, this is your setup. So when it says, I'm on a course of 125 degrees, I'm gonna do that in blue. Would you agree that 125 degrees is something like this? Now, I don't know exactly where it is in there, but would you agree it's between 90 and 180? So put it in there, label it like I did, that's 125 degrees. Now, how long is that little vector I just drew? The ship is traveling at a constant speed of 10 knots. How many of you have heard that word knots before when used in a navigation type problem, like an airplane flying or whatever? Knot is a unit of speed. It's nautical miles per hour. So when you get in your car and you drive 50 miles an hour, those are statute miles, land miles. When you're going great distances, you use nautical miles because you're traveling around the circular globe. A knot is nothing but miles per hour, nautical miles per hour, but it's miles per hour. So if he is traveling 10 nautical miles per hour for 4 hours, how long is that blue vector? 40. 40 miles, nautical miles. Now, he changes course. So I'm gonna set up another little compass right here. Because he's changing course. And now he's on a course of 195. So would you agree 195 is like, probably not that far out. I'm not gonna be super picky. Would you agree it's like this? just a little bit past 180. Now, how come I made that one so short?
Because it's a fourth of
Because
the
he's
distance.
only going for
1 hour.
1 hour? So he's still going 10 miles an hour, but he's only going for 1 hour. So now that one is just 10? Again, I'm not getting out a ruler and measuring it. Make it shorter than the other one. And now, he's right here. And the problem is finished. Because all you had to do was draw it. There's no question attached to it yet. Okay, B, same thing, we're just drawing it. I'm gonna set up my compass. And what is my airplane doing? He is flying at a speed of 250 miles an hour. Remember, not miles per hour, just a speed. 250 miles an hour for 3 hours on a course of 50 degrees. I'm gonna reposition my compass. All right, where's 50 degrees? Like right here? So there he is. 50 degrees. How long is that vector? 250 miles an hour for 3 hours. $750 miles.
Oh, you multiply it.
Right? Now, you're gonna change direction, right? Yep. So, let's put another compass here. Now what direction is he flying on? 350. Now wait, 350, isn't that almost straight up, not quite? So 350 is gonna be out here like this. Because all the way around is 360. How long is that one?
600.
That one is 300 for 2 hours. That one's 600. So I'm gonna make it a little bit longer. Would you agree it's not quite as long as the blue one? And now he's sitting right here. And we're finished with that. Okay? So what I'd like to do now is, let's get out our chapter, section 4-8 homework.
You're blessing us by keeping these homeless.
Huh?
You're blessing us by keeping
I know, I'm so nice. I keep telling everybody I'm nice, nobody believes me. And 4-8. I'm gonna sign it. 4-7 is gonna be due on Monday. 4-7 is due on Monday. And if Phoebe lets me get going on 4-8, I might get that done, so that won't be due on Monday. Alright? So I wanna start 4-8 from the bottom up, because I don't know if I'm gonna get it all done, and I wanna make sure we do those last 2 problems. Why do I wanna make sure we do these last 2 problems? Because they are on tomorrow's quiz. The front page is this kind of problem on the quiz. All right? So here I go. What's the first thing I need to do? I'm on the 4-8 homework, the last problem. What do I need to do?
Convert it.
Change this into,
180.
Degrees.
so this is 180. 180 divided by 6 is 30. And 30 times 7 is 210. Now, I know what we just did. This is math. This is not navigation. So my labels look like this. I know that's confusing, and I'm sorry about it. Gotta do this. Okay, so where's 210? Isn't 210 right here?
Oh, yeah.
So I make a triangle. And I figure out this angle.
It's 30.
That's 30. Perfect. Beautiful. 180 to 210. So 1, root 3, and 2. And what? They're both negative because I am in quadrant 3. I want the cosine. Here's your angle. Cosine is what? Negative root 3 over 2. Adjacent over hypotenuse.
Mrs. Ford, are we allowed calculators?
No.
No. Okay.
Nothing needs a calculator. Kids, you are capable of taking 180 divided by 2, which is 90, and then taking 90 times 3. Now, I'm not saying you necessarily have to do that in your head, but you can do that. 90 times 3 is 270. Oh, wait, 270.
That's nice.
270 is down here, isn't it? So why did I draw a circle? Because that's what I do when my angle is on the line. I let the radius be 1, and then I figure out what that point is. If the radius is 1, what's that point straight down?
0, -1.
0, -1, perfect. So x is 0, that's x. Y is -1, and r is 1. Sine. Well, we can't really say opposite over hypotenuse.
use
We
your
have to
R.
remember y over r. So y over r is -1. All right, let's work our way up. Number 3. How tall is a tree? So look at what I've done so far. Does that make sense? A squirrel at the top spots an acorn. And the angle of depression, 28 degrees, 10 minutes. Where's the 34 go? A squirrel spots an acorn 34 feet from him. Isn't this where the 34 goes? There's the squirrel, there's the acorn. I need an equation. Sine, cosine, or tangent. Sine. So always sine angle, so sine 2810 equals opposite over hypotenuse. So I'll times by 34. And I'm done, except for typing it in. So we gotta remember how to do this. So 34 times sine 28 second angle degrees 10 second angle units. And hopefully you got 16.05 feet. Right? Okay,
Wait. No, no.
number 2. I have a pole that's 16 feet tall. It's casting a shadow that is 23 feet long. Yes, Titus, right there, that's the shadow on the ground. Find the angle of elevation of the sun. Sine, cosine, or tangent? Tangent. Tan x equals opposite over adjacent. Uh-oh. How do I do this? Oh, inverse. Second tangent, 16/23. Remember, when x is your angle, you have to use the second. 34.82 degrees. We good? All right. Last one, or first one. Draw the path of the plane. Here we go. Here's my compass. He flies on a course of 100 degrees. 100 degrees. Would you agree I'm like right here? How long is that? 2 hours, 300 miles an hour, 600. Now, he changes course. So here's a new compass. And where's he going now? On a course of 195. Down here? How long's that one?
An hour.
1 hour at 300 miles an hour, so it's like half as long as that one, 300. And this is where it is. Okay? So if you are here today, that one is done. However, 4/7 is still due on Monday.